Thank you very much. My name is Jack Chen. I'm so thrilled, excited to be here, as in my research years, I read many publications from Korea, and also a lot of advancement, new technology implementation of AI in critical medicine from Korea. So, and another thing is, I really would like to take this opportunity also thanks in particular Dr. DeVita, and he thanks his leadership to lead the rapid response system globally for the last 2 decades. And I was attending his organized first conference, international conference in Pittsburgh. That's 20 years ago. So it's so glad to see him still leading this field. I'm today going to discuss one of the statewide patient safety program implemented in the state of New South Wales in Australia, which is a real-world case of how such a system be implemented. As today's conference theme is AI-related rapid response system, as all groups also actively working on this field. So I was asked to present some of our thoughts and our ideas about the topics in this area. So we have a lot of things to cover, so we try to go through. So between the flags, so what is the between the flags? Why comes up with these names? Actually, this is names. It comes from Australia culture. Australia have a well-known called surf culture. We have a lot of beautiful beaches. And in Sydney, I came from Sydney, there's a Bondi Beach, there's a Manly Beach. In every beach, actually, there's a lot of people swimming on that. So you will see, this is a typical see this picture. So there's 2 flags with the red and white, the color on that. And every swim beach, there's a lifesaver. Actually, in most popular beaches, there's a team of lifesavers. They are well-equipped, well-trained to come to your rescue if you have some emergency. Okay, so the idea, we use this metaphor, actually, we borrowed this metaphor by the that is Clinical Excellence Commission of New South Wales Health. It's the most important health policy, healthcare improvement organization in New South Wales of Australia. They come up with this jargon term to avoid jargon to implement this system. So the idea is when patients' observations are normal, so it is perfect, okay. If the patient vital sign observation raise some alarm bells, so we will have a system response, like we have a well-organized life safeguard. If you are in a red zone, you will be in emergency. We will have an elevated medical emergency response. The whole idea of that. So this is the whole between the flags idea. It's a closed, we call it closed loop of patient safety net. And following what Michael has described, there is 5 critical components of the whole system. This comes including from the governance structure, how this is being organized across the state. Oh, by the way, the New South Wales, the state has roughly 7.3 million population. How this whole idea system you want to implement across the whole state? What is the governance structure? What is the standardized escalation criteria? Okay. What is that efferent arm, which is clinical emergency response teams? What is actually the education component? How this whole system being evaluated and continuously monitored, and so we can self-learning from the lessons and experience we have been gone through. This is between the flag the system actually have a long history. Before that, so you need to understand that before we implemented in January 2010, that's 15 years ago, and New South Wales has a lot of hospitals already voluntarily take up this called rapid response system. So after the implementation, the first stage, we implemented a general adult patient BTF system. Then we start including new component of that system. So including maternity care, pediatric care, ED care, the ED component of between the flag system. So the whole system actually is a quite a complex multi-component system. And in 2025, New South Wales is even extending this system to including mental health and community care. So this is extremely a broad case, complex system intervention. You might well be interested in to know why you, such a big state, suddenly come up with this idea, want to include in this rapid response system in every hospital. So actually, there is quite a long story behind that. I'm just give that a quick show. There's a tragic story behind this. The tragic story is between the flag system, actually it's caused by a sudden unexpected death of 16 years old schoolgirl. And her name actually is Valisa Anderson. And she went to a school golf course, play golf, a sports event, playing golf, being hit by a golf ball. And she's 16 years old. She brought it into one of the best hospitals in Sydney. Actually, it is very interesting because this hospital happened to be a control hospital in all 23 hospital cluster randomized trial about effectiveness of the medical response system. Actually, they are one of the control hospitals. After the ending of our study, they didn't take up the rapid response system. The girl was brought into that hospital, then 2 days later, she was died. She was dead. And we had the Royal Commission inquiry into that, presided by a retired judge called the Peter Gunning Inquiry. And the Peter Gunning Inquiry, through a systematic review of the New South Wales healthcare, and in particular this case, they identified there's many medical mistakes has been made, and the wrong medication lost the sort of, the rapid deterioration was not detected, and the poor communication. So it's lead to the first recommendation after this Peter Gunning's inquiry is to establish a statewide, that's focused to New South Wales, a statewide rapid response system. So that's why comes the Clinical Excellence Commission. They organized all the academics, organizational resources to develop this such a system. So I'm just a quick get through with the governance architecture. We said there's 5 critical components. With the governance architecture, there's actually 4 layers. From the state level of governance to the local health district governance, to the hospital CEOs, to the unit manager. Each of these layers have a clear responsibility, guideline, policy directives. So this is extremely key, important part of the whole system. And after that, there's with this standard escalation criteria. This is New South Wales Health has a systematic redesign of the all patient charts. That's another enormous effort that New South Wales Health has put into that. The key, it is that design, it is a 2-tiered system, that's what we call it. It's not the 1-tiered system. So there is a yellow zone, which is you in sort of when you reach that sort of level, you sort of activated a clinical review by your work team. That's within the 30 minutes. But in the red zone, that's medical emergency, you will a multidisciplinary rapid response team will be called. So the activation criteria, actually the New South Wales Health, we decided to use a simpler one, just use the single criteria, each of them, if you reach a certain threshold, you will activate, you are activated, and you can activate that. Among of them, because we not have enough time to discuss exactly that, there's one critical factor or the calling criteria we call the worried. What does that worried means? Any nurses, you're concerned, you are uncertain, you are encouraged to call. There's no blame, there's no reason to ask. As long as you feel worried, you're concerned, you have a clinical intuition, you call. This is extremely critical criteria we have been encouraging within this system for all the healthcare workers to do it. And there's a systematic redesign of the every observational charts. So within this two-tiered system, each of the system has a team, standard team training. And among that, there's also a critical component I need to particularly mention. It's underneath of this picture, which says any family members, and your cares, and your patient yourself. If I feel unwell, I want to activate this system. You are encouraged to do so. So this is what we call a particular program called REACH. This is a standardized policy. We have implementation protocol implemented in every hospital. So this is to tell you, this is a very unique, very complex policy guideline within such a system. So within education, there's actually, we have a tiered education system. So there's a for all the staff, there's a basic recognition training. For the clinical medical staff, we have the more complex called the A to G assessment, the airway, the breathing, all the tiered sort of criteria. We also have a communication protocol training called ISPA. So this is also critical. A lot of medical error, patient deterioration is due to poor communication. So team communication. This is also have a specific clinical review pathways. That's for all the clinical staff. For the rapid response team per se, there's also clearly the specified training criteria. We also actually considering this is just not a one-off, actually. This is annual rehearsal. We have this annual rehearsal, so it's repeated because you will have new medical staff, new nursing staff. So this education is a continuing process of that. With the evaluation or quality improvement component, that's what Michael has mentioned, we particularly have this system with the CEC leading that. Every hospital, every local quality improvement unit contributes data to the centralized clinical excellence commission data repository. We also have external hospital auditing, so they need to contribute in that. Third one is just my group actually has been academic research evaluation partner. We built this partnership with CEC. We independently seeking research funding to evaluate the effectiveness of such a system. So this is the picture, give you a broad scope, what's the subcomponent of that. We have a general adult component, we have a maternity, we have a pediatric, we have a neonatal, we also now have a new mental health component of that. Each of them have their own activation criteria, calling criteria. So this is, and also now we are actively considering to extend it to the community care. virtual care. Of course, in the current system, the ICU and operation theater CCU were not included in this whole system. Now, I'm going through talking a little bit more about the evaluation. There's many article has been published on this system per se. I'm just focusing on 3 all groups have conducted the largest study on that. The first study we provide a general evaluation of overall as a system of the outcome of the BTF. The second study, we are particularly look at the women at different age groups. Why? Because New South Wales has this standardized maternity early warning system and rapid response system component. So we want to know whether such a component actually achieved its purpose. And actually so far, there's no any published study specifically address that. Even we have a different maternity calling criteria system in place in different countries. And the third one, we look at into sepsis as well. And because this is a part of sepsis, is a part of failure to rescue component, it's a critical component of the rapid deterioration. So we started looking at the whole septic patient which is admitted in ICU to compare them with those patients has not in ICU has no sepsis. And for this ICU patient, we look at them actually in a quite comprehensive way, not in ICU. We look at the out ICU results. We look at them out of the hospital results, so we can have a comprehensive, complete picture of how this implementation of the BTF, the impact on this group of patients. So the first study, just give you a bit more detail, the technical side of thing. The evaluation of this complex system is extremely complex, methodologically and statistically and conceptually. So there is both. And this is a method we did, a method we call segmented regression, interrupted series segmented regression. But what this method for is, but basically it's try to adjust historical impact. Because, as I mentioned in the time charts of the implementation of between the system, before we have this system, already have 70% hospital. They already had their own type of the rapid response system. You have this statewide standard system. Does this add on the already existing system? So this is to try to tease out of this historical trends. So basically, what we also define a critical concept. We find this is what outcome, what it is mostly important one. We choose this, this is the first time in rapid response system evaluation, such a concept was adopted. That is the no mortality, the death in the called no mortality DRG groups. This is, we find this is critical important, much clear. Why? Because people die due to many reasons. They actually could be come into hospital, have a natural cause to die. It's not supposed to be, it's not rapid deterioration to be rescued. Okay, that's nearly the end of their life stage. So that if you use that as an outcome, it always comes up to this question. Is that should be the target or rapid response system? Or actually, this should be part of the palliative care, end of life care target. So it is very difficult to make that differentiation between here. What we try to do, if you are, if the patient died within this no risk group, it is in theory, they are not expected to die. So in that sense, it's approach what is called unexpected death, the concept. This is the first time actually we demonstrated use the most we believe, a valuable-based methodology to approve that. There's a 20% of reduction of this unexpected death overall. So this is critically important. This one results per se estimated there's 1,580 patients. This is called unexpected death. Life could be saved. So we just extrapolated to the Europe and to the United States. It's over 70,000 patient life could be saved. And to the Europe, over 100,000. That's unexpected, it's unequivocal. This is more like to show such a system really achieved such a fantastic purpose. The next paper, we give the detail. I'm not going into too much detail. Basically, the same concept, same sort of interrupted time series, segment regression methodology. We find actually it reduces unexpected death or death in low risk diagnostic criteria by significant count among the age group among 35 to 54. We clearly demonstrated that. So we also show that it also reduces unexpected death among aged patients. The third paper, there's a lot of data here in a nutshell, which is the sepsis patient in ICU survival actually has been improved after the BTF impact. But there is after the BTF, every leading indicator has been significantly improved before, after for sepsis patient, and also for non-sepsis patient, but the gap actually has been still existing between sepsis patient and a non-sepsis patient. So in overall, actually, the BTF from the over actually 1 decade or continues the work with the CEC and our evaluation, it really demonstrated a sustainable clinical outcome improvement. And also we find, even with a simple, this called the simple trigger, simple coding criteria-based trigger system, plus this empowerment varied category, we still can achieve such an outcome. This is an important finding we have found. Apart from that, we also find some other benefit beyond what we call mortality. It reduced ICU length of the stay. Okay, particularly for sepsis patient, it is reduced failure to rescue. It is flattened the hierarchy of the hospital system. As I mentioned, anyone can call, even family members, cares can call. We have a cultural expectation of the escalation of that. So now we have 10 minutes less to give you a quick overview of what our struggle and our thinking about the AI-driven clinical deterioration prediction. There is a well-known problem, and it's a 20 billion. There's medical errors, and a lot of them could be prevented by early detection of the deterioration. It's cost United States $20 billion. That's a wide-cited statistics. So there's about 2% of adult patient admission experience some unexpected deterioration. So there's a non-history. There's this $20 billion question: can we save some of their money through early detection of the rapid deterioration of the patient? There's also some argument in theory, what I'm called, that's in theory, why AI deterioration prediction algorithms could be functioning better. Okay, it's a multivariate interaction. That's we always know. The human brain have a little capacity, as John Lewis clearly demonstrated that, and the temporal pattern, the time, we can model that much clearly. And we can have a dynamic update of every 15 minutes, we can automate that. We have a personalized, we call it personalized medicine, personalized predicting algorithm, taking into account many of your personal information. And another very important thing is the new machine learning algorithm, they even can model this missing as a signal. So for example, if you're the lactate patient with no joint, actually you could learn from data, actually this patient could be, it's due to they are quite stable versus non-stable. If non-stable, usually there will be joint. So they can learn from data themselves. So this is all the in theory, why machine learning multivariate is so attractive and all that. But, I have this but, and then a systematic review conducted by, there are two of that. One is just published last year, 2025, and one is published 2024. And I'm highly recommended every person who interested in such a system should have a careful read of these two systematic reviews. And there's a problem we call the authors claim that's a heterogeneity problem. I think that's just what it is. The author actually, in the latest review in last year, just published 2 months ago, there's 315 decision alternatives across 13 design factors. This is just to tell you there's many things within how do you develop such a system, how do you implement, how do you select the model you think that's right. People all based on different opinions, different rationale, different threshold, different way in doing different things. And one of the critical part of them is the outcome, as I mentioned. What is the outcome we should build our predicting system? There's among the 12 developed, that's called deployed. The author reviewed deployed. There's hundreds of papers. They're not deployed. They're just doing modeling, developed a new algorithm. This 12 deployed system does not include, have 10 different outcome definitions. So they are basically have different ideas. What should be predicted? What called a rapid response system outcome as a label. So this is actually make anyone to try hospital to think of which one should I adopt. This is make it quite difficult. Okay, there's many other issues with the algorithm. There's a huge development with the new machine learning algorithm. What most of the deployed system employees do quite a traditional one. The most popular one, of course, is logistic regression as a machine learning algorithm. So, and the variable, this is also important. What a predictor? Yeah, machine learning give you a lot of this potential with 12, among the 12 deployed systems, that's a 4 to 111 system, okay, per system. Actually, the 226 distinct, total different variable, including this system. So we can see there's a huge variety of that. And there's also a lot of critical questions that need to be asked, and the rationale need to be provided. So the author developed the 9 of them. I have much more questions to ask. So give you a good picture is there's so many different decisions being made. They are critical on the performance of such a system. But what we lacking is we're lacking a consensus. We're lacking of consensus, particularly within the rapid response system or AI-based rapid response system community. What is something should be acceptable. Another critical one I find, that's my particular critique to current evaluation, is people barely describe a critical metrics in evaluating your rapid response system, AI-based one. It's called AUPRC, Area Underneath Precision Recall Curve. This is the full name of that. It's not the popular AUROC. This is well known. This AUROC is not a reliable global measure per se, only for rare event. We call it the rare event. It is called a very popular event. That's a good metrics, but for a rare event, this is not a good event. The typical case, just give you a very simple case. If within the AUROC you have a same, if at the same sort of sensitivity level, you could have an AUROC 0.85, that's better than 0.80, but you could have a positive predictive value. That's actually another term called precision. In the matrix jargon, it's 25. Another is 0.80 AUROC. It's worse, but its PPV, positive predictive value, is 35. It's much better. That means you have less alarm fatigue from this model with lower AUROC, but you perform at the same sensitivity level. So this is often happens, but in all the published study within that, this is even more so for unexpected deaths, for cardiac arrest, because they are quite rare events these days. So this is a critical thing. In the paper published, in the system established, they are not often being described, actually. There are even some paper discussed that, they are not discussed in a clinical meaningful way. So my recommendation would be, in the future, all studies should take that in, should report both of these metrics. And this needs to, that's a critical technical question, the class imbalance question, with when we build this such a system. And then we come up the third my question is, in the current system, hospital have huge amount of data from the clinical vital sign to waveform to that, but we have not actually, in rapid response system sense, to try to combine them all together. Okay, we have image data, we have a time series, we have clinical notes. That's critically important, particularly nursing notes. So how do we combine them and to build a better system? So that's still unknown. So the future, my 9-point wish list for the future of whole field, I think, as a researcher, developer of AI, rapid response system, we should actually explore further about different time series model. But I mentioned that currently we only use logistic regression model, which does not actually, cannot handle the time series data in a native way. You have to have an engineer feature to try to extract some of them. And the most popular ALSTM, non-short terms memory, GRU, and in particular transformer-based architecture actually holds a lot of promise. A huge amount of research has been done in a machine learning field, so that is how do we integrate that into our field. And the second is a multimodal integration. I have mentioned that. It's not only the NAPS value, nodes, and the images and wave data, huge amount of research has been done. And close to my heart is this concept. How do we combine the AI-related rapid response system with AI-related end-of-life system? Okay, so if we can combine them together, we often target the wrong patient. Okay, and there's a multitask training. Can we combine all these different outcomes together? We model them together. Now it's technically entirely possible. And we also have different rapid response teams. We have a cardiac team, we have a rapid response team, we have a pulmonary embolism teams, we have a mental health teams. Can we organize in a holistic way in future, this model, and all this concept that we said, most we try to develop it within ICU. Can we extend it to ICU as well? And we, wireless monitoring, Louis John has mentioned, now the technique is there. How can we integrate that into our AI model? And extending to community, and last one, but least one, the exciting development of generative AI agents, multimodal retrieval, augmented generation, the RAG for our system. This all hold great future. So my future thinking for all local laboratories, AI-based, is a fusion of the between current system with future, a lot of new, scientifically verified system for use the best possible methodology. So thank you for your attention.